Welcome to the world of extreme constraints. The 1K byte challenge isn't just a hobbyist competition, it's a fundamental exercise in digital efficiency. While the average modern web page now exceeds 2 megabytes in size, developers in this community attempt to build entire games, synthesizers, and visualizers within just 1,024 bytes. This disparity highlights a growing divide in software engineering, the gap between developer convenience and user performance. Today, we're exploring why this challenge exists, how it works, and what it teaches us about the bloat that defines the modern web experience. We'll look at the technical tricks used to squeeze logic into tiny spaces and ask ourselves if we've lost the art of being lean in our pursuit of rapid feature delivery. Let's dive into the architecture of the small.
To understand the challenge, we first have to look at what we're up against. In the early 2000s, a web page might be 50 to 100 kilobytes. Today, that number has ballooned by over 2,000%. A single hero image on a modern landing page often weighs more than the entire operating system that sent humans to the moon. We've reached a point where Hello World in some modern frameworks requires downloading hundreds of kilobytes of JavaScript before a single pixel of application logic runs. This is the bloat, a layer of abstraction upon abstraction that simplifies development but complicates execution. While hardware has become faster, software has become heavier, often negating the gains of Moore's law for the end user.
So what exactly is 1024 bytes? In a world of gigabytes, it sounds like nothing. It's roughly the length of a single long paragraph of text. To fit a working program here, you cannot afford the luxury of libraries. No React, no Tailwind, no Lodash. You are writing raw, goffed JavaScript or even assembly-like instructions. Every character matters. A single variable name like user count is too long. You use U. A space after a semicolon is a wasted byte. You begin to look at the language not as a tool for expression, but as a puzzle of entropy. You use bitwise operators instead of math functions and exploit browser quirks to save 3 or 4 characters. It is a return to the craftsmanship of the 8-bit era.
Let's look at these specific techniques. Golfing is the art of reducing source code to its absolute minimum length. First, we strip all white space. Then we use shortened global aliases. Did you know that in a browser, window properties can often be accessed directly? Instead of math.py, we might use something like 3.14. We replace true with !0 and false with !1 to save 2 characters each. Loops are rewritten as recursions or comma-separated expressions. The result is unreadable to humans, but perfectly valid for the machine. This level of optimization reveals the hidden overhead we take for granted every day in our high-level languages. Why does this matter for the modern web? It's about the physics of the network. A 1 kilobyte payload fits within a single TCP packet. This means it can be delivered in a single round trip from server to client. Once it arrives, the browser's parser can process it instantly. Contrast this with a 2 megabyte bundle. That bundle is split into thousands of pockets. If just one pocket is lost, the whole stream stalls. Then, once downloaded, the browser must spend hundreds of milliseconds just parsing the JavaScript before execution even begins. On a low-end mobile device, this cold start latency is the difference between a smooth experience and a frustrated user leaving your site.
We call this the framework tax. We use frameworks like React or Vue because they provide a great developer experience, component isolation, and state management. But they come with a baseline cost. Even an empty project starts at a size that would make a 1 KB challenger faint. The argument is often that developer time is more expensive than computing power, and in many cases that's true. But when every site adopts this mindset, the cumulative effect is a web that feels sluggish despite 5G connections. The 1 KB challenge reminds us that we can do more with less, challenging the assumption that modern features require massive footprints.
Look at some of the JS 1K winners. These are fully realized 3D engines, procedural music generators, and physics simulations, all under 1024 bytes. They achieve this by leveraging the WebGL API directly,
using mathematical constants as data and generating textures on the fly instead of loading images. They treat the browser as a virtual machine. This reveals a profound truth. The browser is incredibly powerful, but we often use it as a simple document viewer wrapped in heavy abstractions. When you remove the layers, you find a high-performance engine capable of incredible feats with minimal input. It's a lesson in tapping into the native power of the platform. Even the way we measure size is a game of math. When we say 1 KB, we often mean the size of the file after gzip or Bloat compression. Compression works by finding patterns and replacing them with shorter symbols. In the 1 KB challenge, developers intentionally write repetitive code that compresses better. This is a counterintuitive skill. Sometimes adding more code makes the final compressed file smaller. This deep understanding of Huffman coding and dictionary-based compression is what separates the masters from the novices. It reminds us that size is not just about character count, but about information entropy. The less random your code, the smaller it can become.
How do we apply this to our daily work? We don't need to write golfed code for our day jobs. That would be a maintenance nightmare. Instead, we should adopt a performance budget. Ask yourself, do I really need this 50 kilobyte library just for one utility function? Can I use a native browser API instead of a polyfill? By setting hard limits on bundle sizes, we force ourselves to be more creative and intentional. The 1 kilobyte challenge shows us that constraints aren't just obstacles, they are catalysts for better engineering. When you have less to work with, you are forced to understand your tools more deeply.
In an age of abundance, there is a quiet beauty in minimalism. The 1 KB challenge is a reminder that software doesn't have to be heavy to be powerful. It's a call to respect the user's bandwidth, the device's battery, and the purity of logic. As you go back to your modern frameworks and massive build pipelines, carry a bit of the 1 KB spirit with you. Efficiency isn't just about speed, it's about craft. Thank you for watching. If you enjoyed this deep dive into code optimization, consider subscribing for more technical explainers. Until next time, keep your code lean and your logic sharp.